Welcome to the one-day webinar on use of slag sand and GGBS in sustainable concrete constructions by Dr. Ganesh Vengala, Head EDC, Associate Professor, Department of Civil Engineering, PV Siddhartha Institute of Technology. Welcome you, sir. I request our principal, Professor Kolla Nagasrinivas Garu, will introduce about the webinar and the spokesperson, Jagadish Garu. Thank you. Nagasrinivas, sir.
Thank you, Uday. Good evening and welcome you all to the webinar on use of slag sand and GGBS in sustainable concrete construction by Chalapathi Institute of Technology, Motadaka. Coming to our institution, CIT Motadaka was established in the year 2008 by Sri YB Anjaneyal Garu with the main motive of bringing down the technical education to the rural people. Since the inception of the institution, we are giving topmost priority in imparting good quality technical education by conducting various programs like workshops, faculty development programs, guest lectures, national and international seminars, etc. to the students, faculty, research scholars, and the people from the industry. Due to this COVID pandemic situation, we are conducting series of webinars and faculty development programs, and we already successfully conducted various programs belonging to different branches. Today, we planned a webinar program on use of slag sand and GGBS in sustainable concrete construction. As a civil engineer, we all know there is a lot of scope for research activity by replacing various constituents of the concrete. This is going on since several years. Coming to this GGBS, ground granulated blast furnace slag, it is a hydraulic binder, that is a cement which has known for several years, and it improves the quality and durability of the concrete, and almost its production is virtually CO2 free because of its various advantages like solar reflectance, that is 20% increase in the reflection of sunlight by use of this GGBS, because of its durability, because of fire resistance, and because of reduction in CO2 emissions. This can be used as a quality sustainable concrete. Similarly, a slag sand, it is also a good alternative to a river sand or filter sand or manufactured sand. And as per experts, they have recommended the use of this granulated blast furnace slag, which is generated as a byproduct during the production of steel. And this slag, along with a chemical mixture, can also be used as a replacement to river sand. And by using these two, we can bring a sustainable concrete construction. For this webinar, we invited an eminent personality, Dr. Jagadish Vengala. He has a vast experience both as a research worker, our industrial experience, and also an academic experience. At present, he is head of EDC, Innovation and Incubation Center, and also associate professor in civil engineering, PVP Siddhartha Institute of Technology, Vijayawada. Thank you, sir, for accepting our invitation. I would also extend my thanks to Professor Uday, our IQAC coordinator, for making elaborate arrangements for conducting this webinar. I also thank our civil engineering faculty who are instrumental in putting this webinar today, and I request all the participants to stay for the whole program and get maximum benefit from the webinar of Dr. Jagadish Garu. Once again, I express my thanks to Dr. Jagadish Garu for giving this webinar. Thank you, one and all.
Thank you, sir. I request Jagadish Garu will continue with your lecture, sir. Welcome you, sir. Jagadish sir.
Can you able to hear any? No?
Yes, sir. Yes, sir.
Yeah,
Yes,
yeah.
sir.
Yeah. Good evening, one and all. I'm thankful to Chalapathi group of institutions and particularly Professor Nagasrinivasa Garu, Principal and IQS Coordinator for inviting me to deliver a talk on one of the most important topic, use of supplementary cementitious materials, wherein I'm taking GGBS and slag sand as an alternate for the concrete construction. So this work is a combination of my research experiments with my students and faculty internship carried out at JSW Cements, and also some of the work I have carried out along with the JSW people in Ballari. And I thank my students and some of the JSW personnel for allowing me to conduct some experiments and associate with them. So coming to the topic, my presentation, outline of my presentation is, I'm going to explain how slag sand is an eco-friendly fine aggregate. And then I give some overview on slag as coarse aggregate. Then I explain about GGBS as used as a supplementary cementitious material in concrete. And then one of the research work carried out with my students, that is use of GGBS in part replacement in manufacture of solid concrete blocks. So this is my outline of my presentation. Yeah. When it comes to the alternatives, particularly for aggregates, we all know that many of the places river sand is banned, wherein it creates a lot of burden on the environment, and people are looking alternative aggregates because there is a dearth in utilizing the natural river sand, and you have a huge quantum of requirement, and also you need to look for the quality and properties of alternative river sand, wherein it should match with the natural river sand. So one of the future alternatives I can say is slags. And when you look into other countries and even our country, these aggregates have proven as suitable material for replacing natural both coarse and fine aggregates. I'll explain you even how slags are used as a coarse aggregate in concrete. In most of the developed countries, use of slag aggregates replace natural river sand and rocks. It's a well-established process because most of the countries, steel production is common, and then a lot of slag comes out from the steel production. When you look into the basic definition of slag, you can see this is a blast furnace slag. You can see the picture over there. It is a non-metallic product, consists of glass, mostly contains silicates and also aluminosilicates of lime, which is produced in steel industry while steel making. It is basically a byproduct of metal smelting process under quality control conditions. Why I'm saying, because you maintain some kind of temperature and then later you do the quenching, wherein you get the slag along with the main product like either iron or steel. So this is basically a byproduct. As I mentioned, it is obtained by rapidly chilling or quenching the molten slag, either by water or by air. So you have both types, air-cooled slag you get, or by quenching with water, you get a different slag. When you compare with the natural river sand, this particular sand doesn't contain any organic matter or clay, silt, shells, because you don't mine near the riverbed. Okay, so this it's a byproduct from the steel manufacture. When you look into the slag generation, so both into iron making or steel making, you need to understand the difference. What you do, you take the iron ore and then coking coal and mix along with some fluxes. And in iron making, typically you get per ton of iron production, you get 350 kgs as a byproduct. What is that? Slag. And similarly in steel making, you get almost 200 kgs per ton of steel production, you get 200 kgs of slag as a byproduct. But most of the slag which generated as a byproduct is dumped in the backyards of these steel plants earlier, initially. So these are some of the slag dumping units at various places and at various steel industries. So whatever you get, the byproduct slag from iron making, we call that as a granulated blast furnace slag, because here you quench it with water and then the slag what you get is a granulated blast furnace slag. Typically this kind of slag, you can use it both for coarse aggregate, fine aggregate, and even for making the GGBS. That means this granulated blast furnace slag, you grind it to the required fineness and you make the ground granulated blast furnace slag, GGBFS. When it comes to the steel making, what you do, generally, quenching will be done by sprinkling a little bit of water and you do the air cooling. So what you get is a air-cooled LD slag. This kind of slag, we generally use it as a replacement to the coarse aggregate. There are some issues, whatever byproduct you get, the slag as an aggregate. One thing is it should match the natural aggregate specifications. We all know that when you have to use aggregate in concrete, it has to satisfy the requirements of IS 383. So it has to match the IS 383 requirements, and whatever obtained, directly obtained slag from both either steel or from iron making, the properties are different from the natural aggregates. And initially there are no standards or specifications to use these alternative aggregates in the concrete. Initially, I'm talking about. Later in 2015, they included that you can use alternative aggregates, which are, that means manufactured aggregates in the concrete. So now I talk about granulated blast furnace slag as fine aggregate. That means in place of river sand. When you test river sand as per IS 383, it has to meet some of the specifications, like it has to satisfy size requirements. Size in the sense gradation, like zone 1 to zone 4, you know that zone 1 is coarser and zone 4 is finer. And also there should be limited deleterious material and soundness properties and bulk density. Typically the bulk density of the sand is between 1500 to 1650 kg per cubic meter. Specific gravity, as we all know, 2.58 and 2.6, 2.65 natural river aggregate. And water absorption properties also, it should be less, maybe less than 0.5 or less than 1 if you take the natural river sand. So granulated blast furnace slag, if it has to replace the sand, it should meet the specifications of IS 383. So when you look into the natural river sand as per IS 383, generally we use zone 2 or zone 1 sand in concrete, sometimes zone 3 also. Deleterious material, it is approximately 0.2%. So density, as I mentioned, it varies between 1400 to 1700. Specific gravity also between 2.6 to 2.8. It depends on the river to river. And water absorption varies. But when we check, when they tested granulated blast furnace slag, if you wanted to use it as a river sand, it has to meet all these requirements. But when they check, density is between 1000 to 1100 kg per cubic meter. So what is the water density? 1000 kg per cubic meter. So if you have to use it, it should match with the river sand properties. And specific gravity is also less when compared with the natural river sand. It is 2.3. Water absorption is also more, that is 4 to 6%. So if density is less, specific gravity is less, and water absorption is more, that means some kind of pores that are present in this granulated blast furnace slag material. That means some kind of vesicular structure which contains small pores in this particular slag. So what they did a microscopic studies comparing river sand and granulated blast furnace slag. Because if you have to use it as a river sand, it should meet the properties of IS-38. When they look into it, as you know that it has got a lower density like 1000 to 1100. It contains a vesicular structure, and this structure contains the presence of micropores. That means you have more pores, so that water absorption will be more when compared with the river sand, and obviously low density, and also specific gravity is less. So when you have to use it, you have to match with the requirements of the IS-383, and it should match with the natural river sand properties. So what they did, they changed a little bit of processing of this blast furnace slag by changing, shaping and screening in the process itself. Okay, so they've changed they've altered the granulation parameters, and they did some kind of shaping and screening in the machine. That means, when they, while making. By doing so, the particle shapes of this blast furnace slag have improved. And you all know that when you use a flaky or elongated coarse aggregate particles, it creates more voids when compared with the cubical shape aggregates. So you have to reduce the sharp edges and needle shaped particles. By changing the parameters, they could be able to achieve a better property particles, and the processed granulated blast furnace slag, which is earlier giving low density, which is earlier giving more water absorption, less specific gravity, now improved after processing, and these properties are similar to the river sand. You can see here the microscopic pictures. These pictures was taken from the JSW plant. And even the gradation, when you compare river sand with granulated blast furnace slag and processed granulated blast furnace slag, the size and shape parameters improved, and the processed granulated blast furnace slag gradation curve matches with the natural river sand gradation curve. So when you look into the properties after the processing, it is almost 1500 kg per cubic meter, the density after process. And even the specific gravity is almost like 2.65, and water absorption is less than 3% as the pores reduced and vesicular structure is minimized, so that you got the processed granulated blast furnace slag. The properties are equivalent to the river sand. Some of the advantages other than the density, specific gravity, and water absorption is main. Most of the river sand you collect from the riverbeds. So these contains marine products, oversized materials, clay and silt. What is the problem with the clay and silt? We all know that. The clay is an organic material. Once it goes inside over a period of time, comes out, and then it leaves pores inside the concrete, which is harmful to the concrete. So when it comes to the comparison between the processed slag sand to the river sand, some of these marine products and clay silt is avoided when compared with the river sand. Even the microscopic examination, you can see when compared with the river sand, shape is similar to river sand after process, and it is similar to the even microscopically. It is almost similar to the manufactured slag or manufactured sand. Or so you can use this processed slag sand either 100% or in combination with the river sand or crushed rock fines, whatever combinations you can use. So chemical tests also conducted for this processed slag as per IS 383, as I mentioned. They've conducted soundness tests, chlorides, sulfates, and pH. So when they check, it is much lower than the maximum requirements. Suppose take the case of magnesium sulfate, maximum 15% is allowed, but this is only 2%. And even alkali aggregate reactions. Once you match the river sand requirements, this process is slag, you need to see how the properties of both mortar and concrete when you use it as a fine aggregate. So some of the tests were conducted, you can see here. So one thing is one can check the flowability. So how the flowability with the river sand and how the flowability with the GGBS. You can see the top portion both are with the river sand and bottom pictures are with processed granulated blast furnace slag. And even the durability tests are conducted and these are giving good results. You can see the comparison of strength when you use fine aggregate of 100% natural river sand to various percentages of GBS, that means granulated, and processed granulated, and with the combination of 50-50 and then with the natural sand, M sand, and crushed rock fines. You can see the strength is almost similar. Okay, when you compare the natural river sand to processed one, so it is almost similar or a little bit 1 MPa we don't really consider, but it is almost matching. Even when you combine with other materials like natural river sand, manufactured sand, or crushed sand, it is almost giving the same strength. This is about the initial trials. So based on the trials, they've revised, they've made the amendment in 2015, as I mentioned. First time, earlier they were mentioning only river sand in the sense that derived from natural resources you have to use. That means river beds, deposits, rocks, so on. But first time they've included that as manufactured aggregates produced from other than natural sources. That means you can now use granulated blast furnace slag as a fine aggregate replacement. So that amendment, they've made it in IS 383. So what IS 383 2016, that is revised in 2016, it's a third revision. What it talks about, different aggregates. Okay. So we have already seen iron slag aggregate, that is processed blast furnace slag aggregate. What IS says. So it mentions iron slag obtained from producing iron in blast furnace, from iron or steel plants, and molten slag. Temperature is around 1500 degrees centigrade, suddenly taken out from the furnace, cool it to form different types of slag products. So one is cooled iron slag aggregates, another one is granulated iron slag aggregates. In the first case, quenching with water and then cooling and crystallizing. In the second case, granulated iron slag aggregates, it is like quenching rapidly with large volumes of water. So this is the difference between the air-cooled iron slag aggregates and granulated iron slag aggregates. And this is a typical plant wherein processed slag sand is getting prepared at JSW Cements, Ballari. It's in Vijayawada. It's an entire area, the factory is. A lot of advantages, you can use it in airport runways, highways, flyovers, buildings, suitable for various purposes, concrete, plaster, mortars, so on. Anyway, I will explain you one by one. Okay. Maybe questions I will take at the end. Yeah. So what they have done, once they got that you can use it, they started using within the plant. So this is where slag sand is used in foundations, flooring, roads within their complex, and even the paver blocks they made using the slag sand. Even the plastering they made using slag sand. So within the steel plant, they've started using it. So I was standing here during my visit to JSW plant, wherein I almost 1 month I had a association with these people. We did some experiments at various sites and so on. And they've used it even for floorings for heavy loads, wherein Professor Nagasrinivasa, principals have told in the initial comments, is very good in abrasion also. So after using this slag sand within, they started supplying to nearby places. So nearby city is Ballari, nearby town. So wherein they started supplying to Nirmit Kendra buildings, that means state government projects. They started using for the plastering applications. You can see here, plastering work is going on, wherein the slag sand is used as a fine aggregate. So this is about the slag sand used as a fine aggregate. Coming to the coarse aggregate, as I mentioned, two types of slags. It comes as a byproduct. One is iron making, and second one is the steel making. Iron making, you had a byproduct of 350 kgs per ton. In the steel making, you had a 200 kgs per ton. So steel slag aggregates, it is cooled down from 1400 to 1700 degrees centigrade and suddenly quenched in air. That means this is air cooled SD slag, we call it as. A little bit of sprinkling of water they do. So this is a byproduct, steel slag aggregate. Because you are quenching out in air, the density is much, much higher when compared with the other slag. So the density is almost like 3.2, 3.5 specific gravity I'm talking about. And this steel slag coarse aggregate, you can use it as a coarse aggregate. So they started again using it for internal roads. That means steel slag as a coarse aggregate within the campus. So you can use, if you take the road works, you can use it for all the purposes. One is granular, as a granular sub-base. You can use it in dry lean concrete, these aggregates. And even pavement quality, PQC, you can use it. In the concrete itself, you can use it. You can use it in 3 layers. This is one of the road portion constructed using the coarse aggregate, steel coarse aggregate. You can see a lot of heavy trucks are moving around. Very interesting thing, while coming back from JSW plant, I observed this Hospet Ballari Road, National Highway 63. Gaman people did the work and they've utilized this steel slag as coarse aggregate. You can see this side, the coarse aggregate is lying next to the road. So this is all coarse aggregate. So this is the first time in India, a complete slag-based road that is made, that is Hospet Ballari Road, NH63. So you've seen both fine aggregate and coarse aggregate using using slag as a both fine and coarse aggregate. So now I will come to the GGBS. That is, this granulated blast furnace slag, you grind it to the required fineness and use it, required fineness in the sense finer than the cement. Cement, if you take fineness, the Blaine's air permeability operated test, wherein the cement fineness is like 300 kg per square meter. Okay, this GGBS is much, much higher when compared with the cement fineness. Specific surface area, we call it. So GGBS, as I mentioned, molten slag produced during iron production, not steel, okay? Very rapidly cooled and slags are formed and then grind it to amorphous form And this reactive matter, in presence of lime, it forms further CSH gels because this contains silicates and aluminates of lime, and secondary hydration happens. And you have to grind it to adequate fineness, as I mentioned, and then you can use it as a cementitious material. The processed form of granulated slag, we call it as a ground granulated blast furnace slag. Commonly, we call it as a GGBS. So what IS 456 says, when you look into the IS 456 2000, when you take the IS 456 table, the maximum water cement ratio is 0.55 for reinforced cement concretes, and cement you start with the 300, and then maximum cement you can use it as 450 kg per cubic meter in concrete. At the same time, IS permits, and all this is based on the different exposure conditions, that is mild, moderate, severe, very severe, and extreme conditions. Depending upon the exposure condition, you go for a minimum grade of concrete and minimum cement content and restrict the water cement ratio also. IS permits you to use the supplementary cementitious materials. So GGBS, microsilica, fly ash, methacavalian, alcofines, rice cash. You can see like fly ash and GGBS and microsilica are most commonly used materials. So what these supplementary cementitious materials does, when you add water to the cement, when water is added to the cement during the concrete manufacturing, hydration process starts. We all know calcium silicate hydrate, which gives the strength. CSH gels will form, and excess lime will present. We call it as calcium hydroxide or portlandite. When you add the supplementary cementitious materials like GGBS, fly ash, or any other material, this excess calcium hydroxide, this lime, reacts with supplementary cementitious materials and forms furthermore CSH gels. That means you are filling the pores and making the concrete more denser by adding supplementary cementitious material. But here our interest is GGBS. Anyway, so this is the basic reaction. Normal concrete, you have more pores, but here you have a more CSH gels will form. The concrete will become more denser. So more denser, more strength, and impermeability increases. So because the bleed pockets are covered with excess CSH gels and forming dense hydrated cement paste, definitely increased compressive and tensile strengths you can observe in the concrete by adding supplementary cementitious. When it comes to the GGBS, the replacement levels of OPC with OPC. Okay, before explaining this, I'll just give you overview. You all know that ordinary Portland cement, then Portland pozzolana cement, wherein fly ash is replaced to a percentage of 35% in cement. I'm talking about Portland pozzolana cement, wherein you add the fly ash. And in Portland slag cement, they go up to 65% of the replacement. I'm talking about the cement manufacturing, OPC, PPC, and PSC. But when you're adding supplementary cementitious material, directly adding to the concrete, the replacement levels based on different works all over the world are like this. Particularly ground concrete structures, when you're aiming higher layer strength, one can replace up to 25 to 35. Underground structures, because aggressive environment is there, soil is corroded. Due to soil, it may corrode. So one can go to 35 to 50%. Mass concrete, to reduce the temperature and to strict the temperature control, one can go up to 50 to 65%. And specialty concrete structures, wherein durability is the requirement, particularly corrosion-resistant marine structures, sewage treatment plants, one can go up to 50 to 70%, depending upon the different applications. But what IS is, we all follow IS 10262 to design the concrete mix. Till now, IS 456 or IS 10262 never talks about the percentage of supplementary cementitious materials. But when you look into the new IS 10262 2019, wherein using that you proportion the concrete mix, some of the guidelines given for high strength mixes, they mention out of all the supplementary cementitious materials, you can see GGBS you can replace up to 25 to 50% when compared with the fly ash. Fly ash is like 15 to 30. So I'm just mentioning here, GGBS can be used up to 25 to 50%. You have the code support, IS 10262, and you have well proven test results. Yeah, this is one case study I've taken from our JSW friends. So this is a Bangalore Metro Rail project, phase 2. These are some of the mixes they've used for pile and pier and segment. Both the M35 and M50 grade of concrete they've used. They use the cementitious material up to M35, they've used 400, and 200 cement and 200 GGBS they've used. And pier and segment columns, they've used M50, wherein cementitious material, they've used up to 500. Somebody may ask, like, sir, just now you told like 450 kg per cubic meter is limit, but 450 kg per cubic meter is cement only. You can use supplementary cementitious material up to 600, particularly if you take the self-compacting concrete. The cementitious material, you can go from 450 to 600 kg per cubic meter. Here in this case, they've used 500 kgs. Cement alone, they've used 400. Rest of the 100, they've used the GGBS. You can see the slump at different delayed timings, and you can also see the consistent, like 28 days. It is achieved. Like M35, they got 47, M50, they've got 70 MPU. So these are some of the trials. So you can see here the initial trials before giving the mix to the client. These are the trials conducted. One of my friend, Mr. Yogananda, wherein we have conducted combined project with him. He is from JSW. He was present in this slide. So when you are using GGBS or when you are using admixture along with chemical admixture, okay, you have to look into the compatibility between the cementitious material and the superplasticizer, because you have to, when you have to get a denser concrete, you have to reduce the water cement ratio. At the same time, you have to achieve the workability, wherein you are bound to use chemical admixture to get the workability at the same time strength. So for that, to get the optimum dosage of superplasticizer, chemical admixture, we use the test called marsh cone test. This is a operators, you can see it's a hollow inverted cone with aperture of 8 mm, wherein you pour the liquid, you place the mortar and then open the bottom gate, and then you measure the time required to flow through the small aperture. Basically, you measure the viscosity of the material. Typically, you take 500 ml paste and then fill it in the cone, and then flow time is measured with a different superplasticizer to cement percentages. So flow time versus superplasticizer dosage. You can see flow time versus superplasticizer. You will get a curve like this. After a certain point, even though you add more superplasticizer, there won't be any change in flow time. Typically, this saturation point is 140 plus or minus 10 degrees. You can see that. So these are some of the experiments conducted at our earlier college, BMS IT, with our students. You can see the marsh cone wherein we have placed the mortar and then we measured the flow time. This is the typical mix. Okay. So this is how, okay, when we add the 0.1% of admixture, flow time is 17 seconds, 0.2, 15 seconds, 0.3, 11 seconds. After 0.3, 0.4, 0.5, it is giving the same seconds. So that means 0.3% is the optimum dosage of the chemical admixture. Beyond that, you should not add. So that is how marsh cone test gives you optimum dosage of superplasticizer when you are using cementitious material particularly. So when you wanted to know the optimum dosage of the chemical admixture for a particular concrete mix. Next is very important that I would like to mention here is accelerated curing test. Most of you must know, because many times you go for a number of mixes. So you cannot wait for 28 days. You have to check the strength next day so that any problem is there, you can refine the mix, and then you go with this second trial and then you can check it. So typically, all of you know that how you do it. You cast the cubes and you left it dry up to 23 hours plus or minus 15 minutes. And then you remove the bottom mold, only the bottom mold, including the concrete mold. You place it in a curing tank of water with 100 degrees centigrade. You boil it for 3.5 hours plus or minus 5 minutes. Later, you remove the molds and take out the cube and cool the cube for a period of 1 hour at a normal temperature, and then air dry for half an hour, and then you carry out the compression test. You all know the IS 9012 is the code, wherein you check the accelerated curing strength and projected 28-day strength. The relation is given 8.09 plus 1.64 into RA. RA is the accelerated curing strength, what you got next day after 27 or 8 hours. This is one of the mix, typical mix. We have 100 mm cube with the 12 mm down aggregate. We made the cubes. You can see, sorry, the results are not there. Okay. So that is how you conduct the accelerated curing test. Yeah. I think something is missing. Okay. This is the mix design used in Bangalore Metro Railway, as I mentioned earlier, wherein they've used PCE-based superplastic. Here they've used 220 cement, 200 kgs GGBS, and water cement ratio is almost 0.36. And then slump, you can see it's a collapsed slump, and after 1 hour and after 2 hours, because it has to be placed. It's a flowing concrete. 28-day strength. It is an M35 grade of concrete. They've got 52 MP. This is one of the mix you can see. When you compare with the fly ash, because each of the supplementary cementitious material is having advantage, just to compare with the fly ash for some of the mixes like M30, 35, for fly ash based mixes, you can see in place of 310 plus 80, wherein you have used fly ash, one can go for an increase in cementitious material. Like instead of 80, one can go up to 160 GGBS in place of fly ash, wherein the early strength requirement is a point, okay, wherein you can see the compressive strength what you obtain. Similarly, for M35, in place of 100 kg fly ash, one can go up to 190 kg of fly ash. So you can obviously get the advantage of both the strength and even the cost. If somebody asks me what is the cost of GGBS, you know that cement is approximately, it depends on area to area, 300 to 350 rupees per bag. But GGBS, you get it for 180 rupees per bag. That means half the cost when compared with the cement. So even self-compacting concrete, people are using it, GGBS, because when you look into the self-compacting concrete, the cementitious material itself, you have to use 450 to 600 kg per cubic meter. So you cannot use cement alone, because IS 456 says maximum cement content alone you can use in the self-compacting concrete mix is 450 kgs. Beyond that, if you use a heat of hydration, drying, shrinkage, cracks, all these problems are there. So, you know, the option is number of supplementary cementitious material. Fly ash you can use. So GGBS, they've used it in one of the structures that is Shobha in the Presta. It's a monolithic structure in Bangalore, wherein they've used the M50 grade of SCC, wherein GGBS is used. The slump, what they got is around 650 plus or minus 30, and then compressive strength is 7 days 42, in 28 days they got 63, and at 90 days they have almost got 72 MP. Even 181 days is 78 MP with GGBS. This is a example wherein GGBS can be used in these special concretes. Yeah, this is the same Shobha and the Presta. This is the actual sheet of long-term strength gain. 111 days, it is almost like 224% strength gain from 28 days. Okay. So 28 days is what they got is 33 MPa, and then 111 days it is like 56 MPa, wherein they've used 170 cement and then 170 GGBS for M25 grade of concrete. This is for Shobha and the Presta project. Yeah, coming to the last part of my presentation, that is the work we have done on solid concrete blocks. Very interesting work. When I was head of the department at BMS Institute of Technology, one of the batch students, they approached me. I said, like, let us go ahead with this project. And then JSW sponsored the materials, wherein we thought of replacing GGBS in solid concrete blocks. So students, their friends having 2-3 plants, when they approached me, I asked them to visit number of solid concrete block units in Bangalore. So when they visited, like 15 to 20 solid concrete block manufacturing units in Bangalore, the students, and they have come out with certain points. Why I asked them, I wanted to know what is happening in the solid concrete block units. Right now, what is the thing they are practicing? So when they visited, we understood some of the points we have listed out. There is no proper guidelines for mixed proportioning. And very interesting thing, what we noted, they are using fly ash, they are mixing. Even instead of OPC, they are using PSC or PPC. That means PSC, PPC already contains fly ash or GGBS. But using that cement and again replacing fly ash, because they don't know, because the mix operators and all, they don't know. And consistency of the quality is a problem in plant to plant and batch to batch. And also purely based on experience of the operator or the workers that these manufacturing plants are running. That means the awareness is not there. And also most of the time they used to end up in uneconomical mixes. Either they are putting more cement or they are putting less cement. That is why sometimes you get a very good block, sometimes the edges are torn off, and then you get all sorts of blocks. Having this as a background, we wanted to work on this project. So we started working from the code, because IS 2185 talks about solid concrete blocks. So we just gone through the code, part 1, if you look into it. So there are 2 grades. You can produce 4 MPa blocks or 5 MPa blocks. Very interesting. I'll let you know what is this 4 MPa and 5 MPa. So then we thought of using different materials, like different combinations, only cement and with fly ash, with the GGBS, with the manufactured sand, with the different aggregates, with the different chemical admixtures. A lot of combinations we made, and we did a lot of trials. So these are some of the properties of the materials like cement and GGBS, you can see. These are the properties of coarse aggregate and then fine aggregate. Fine aggregate conforms to zone 2. And these are material properties, water absorption and other properties. So we have taken this project in 2 stages. One is conducting laboratory trials. And then based on the optimum mixes, what we obtained in laboratory, we thought of going to site and do the full scale site trials. So 2 parts in the project we did. So when they went and visited 20 to 25 manufacturing plants, they understood the cement content varies between 200 to 100 kilos. So somebody is using high, somebody is using low. So the range is something like this, 100 to 195, something. So we have taken the cement content between 200 to 100 kgs. So 3 mixes we have taken, 200, 150 and 100. And then we designed the mix more than 5 MPa. And we have, so the first one is getting the optimum mix. And optimum mix, once we get, it has to satisfy 3 requirements as per IS: strength, water absorption, and density. I will explain you. So once the second step, what we did, we replaced the cement with GGBS at different replacement levels. And then third stage, we even did the trials using a little bit of superplasticizer doses to get a better finish. And then last stage, we did the trials at the site. These are the mixes. The first yellow color, 3 mixes are with 200, 150, and 100 kg cement content. And the mixes 4 to 14 are with the cement 150. That is the optimum mix we got, replacing cement with fly ash at different replacement, 10, 43, 37, so on. Okay. And then last mixes are with the replacement of the superplasticizer. That means superplasticizer dosage. So as I mentioned, these are the laboratory trials we conducted. First thing is laboratory trials, as I mentioned. So suddenly the student is very smart. He came and asked me like, sir, in plant, you have an egg laying machine. They don't vibrate. They place, this egg laying machine will place it in that mold, and a little bit of pressure it will give. So I'll show you what is egg laying machine. So then, sir, here vibrating is not feasible. So tell me what we have to do. Then I said, don't vibrate it. Place the cube on the vibrating machine and just switch on, switch off. That means 3 to 4 seconds of vibration it happens just to settle. Okay, so that's what we related somehow with the site practice to laboratory practice, just to know like what is it. As I mentioned, once you get the once you casted different trials, you need to conduct tests, various tests on these cubes. So as per IS, as I mentioned, compressive strength, water absorption, density, these are the 3 major properties one has to look into. So when you look into the IS, so the testing is done, you can see one of the cube, it is 14.2 MPa, one of the trial. Okay, so actually what you have to get is 5 MPa. Fine, this is a 28 days cube. So these are the results we got for all those mixes, whatever I've showed initially. So 28 days strength, if you see, all are passing more than 5 MPa. Water absorption also passing, and density is also passing. So one has a question, sir, what are the limits? Very interesting. IS gives water absorption limit is, as I told, 2 grades. One is 5 MPa grade and then 4 MPa grade. And first thing is density. It should not be less than 1800. That means it is more than 1800. It should not be too low. And average strength, it should be more than 5 and 4. And water absorption, it shall not be more than 10% by mass when you test the water absorption. Okay. Now, sorry. Yeah. Here, I wanted to tell you that compressive strength for cubes, what we will do, we will take the average of 3. But in solid concrete blocks, you have to take average of 8 blocks to report as a average compressive strength. You cannot test 3 blocks and say that this is average. You have to test 8 blocks, 8 solid concrete blocks, and report it. And then minimum strength of individual units is 4. But when you test 8 blocks average, it should it should be more than 5 in case of grade 5, and in case of grade 4, it should be more than 4. These are the full-scale trials we have conducted by taking the optimum mixes from the laboratory trials. So wherein we have considered 13, 33, 50, 57, and 73 percentages. Yeah, this is a casting did at one of the solid manufacturing plant. This is a egg laying machine wherein continuously you make the blocks. Using all these mixes, they've conducted almost like more than 300 blocks they made at the site. Okay, using all those trials. So this is how the casting at site is happening. These people went to Saturday and Sundays and they did it. To tell you, it's a beta project, by the way. So after the cubes are casted, that means the blocks are casted, they're brought back to laboratory. And you need to have the proper, surface. So you apply POP, plaster of Paris, before testing consistent. And they have tested for each trial. Okay. So these are the test results for 7 days, 14 days, 20 days. Each time they've tested 8 blocks. Okay. These are the average of 8 block results. And water absorption also less than 10%. Density is more than 1,800 kg per cubic meter. And then strength also more than 5 MPa, even after replacing 70% of cement. That means 150 kg, 70% replacement with the GGBS. This is once again to remind you compressive strength, how much, density, how much, and water absorption, how much. This is about only the remarks about this particular project, wherein one can use GGBS as a part replacement, and plasticizers can reduce water content, and it will increase the homogeneity. You can, but you should not use excess because it may stick to the egg laying machine sides. And so what from the experiments we understood, the cementitious material about 150 kg is sufficient to produce the required strength. One need not go beyond 150. And even more than up to 70% cement can be replaced using GGBS. I will talk about the cost parameters in the next slide. And there are some constraints like cost increase is there. GST increased the recent after that GST came. And many people lack of awareness about GGBS. So some of the sites, a lot of awareness created after that project, and good quality practices are the constraints still, one has to follow. So we thought of coming out with some guidelines working with JSW, and chemical admixture also has to be tried at the site itself to check the finishability and other things. And we also have to visit number of other sites at different places before formulating the guide. One interesting study what the cost analysis made, wherein if you take a 6-inch concrete block, okay, typically the manufacturing cost comes out around 28 rupees, 28, 29 rupees. Market price is around 34 rupees. Profit per block, you get around 5 rupees. Okay, suppose if you use GGBS. Suppose a particular plant, when you have the plant, definitely you should minimum 2,000 blocks you have to produce. Otherwise, there is no payback amount you get. And working days, if you take 25, so you can simple math if you do, like 3 rupees is the profit per block when you replace GGBS. Per day, 2,000 into 3 rupees is 6,000 rupees. Even 20 days, you take it as a working days, 20 into 6,000, almost like 1 lakh easily, you get the profit. 12 months, 12 lakhs just by replacing cement with GGBS. But as I mentioned, you have to take care of the quality control and the mix of proportions properly. Very simple. And later, JSW friends and popularized based on the trials. They've gone to different places: Jigni plant, Hebbal, Mysore plant, Chennai, Mangalore, Yelahanka, Bangalore. So they've gone to different, and they've created awareness, and they've showed them. They started implementing and getting little more profit in solid concrete. This is the outcome of the project. Okay. And even the GGBS can be used in plastering of walls, wherein cement to sand ratio is 1:5. If you take, cement can be replaced up to 20, 35, even up to 50%. Finishing will be good because you have the more fine material, because GGBS when compared to the cement, and permeability will reduce and shrinkage cracks will reduce because less cement you are using, and you have the increased productivity. And even paver blocks also can be made with 50-50 this thing, and finish will be good. And particularly the problem of shrinkage cracks, particularly in paver blocks, can be reduced, garden paver blocks. Yeah, I'm almost come to the end of my presentation. I would like to acknowledge, Mr. Satish from R&D unit of JSW, and Mr. Dr. Manjunath and Mr. Yoganand from JSW. And these are some of my final year BA students, wherein I have troubled them in their final year project, Mr. Raju and Shiva. And I've used the concrete, we have used concrete laboratory at the time I was working there. Even SLV solid concrete blocks unit, they've allowed us to conduct trials in Bangalore. Okay. This is what I wanted to share with all of you about the GGBS and slag sand and so on. Okay. Thank you one and all. And this is my email ID and mobile number. After the question and answer session, if someone wanted to contact me, you can mail me so that whenever I get time, I'll reply. Over to Chalapathi Institute of College.
Sir, thank you, sir. Do you have any questions? Please raise your hand.
Maybe I think I will, if they can type it in chat, I'll answer, because, the crosstalks will be, If they can type, they can type. I'll just check in the.
Is there in the chat box, sir? You please check it.
Chat box, sir. Where? 1 second. I'll just find out.
How is the durability performance of concrete blended with the GGBS?
Yeah, durability, very interesting question. And thanks for whoever it may be raising that question. Very interesting question. See, if you look into the IS 10262 new code 2019, for particularly tall structures, okay, whenever you are going for tall structures, they have mentioned durability requirements. Okay, one is water penetration test, another one is a rapid chloride permeability test, and another one is initial surface absorption test. So, Amravati construction, HOD towers construction, and that mix was came to one of my old boss. He's now having the company called Strident Technoclinics Private Limited, wherein they've tested the mix with the GGBS, and chloride permeability, the limits are like for tall structures, it should be less than 1,500 coulombs. Okay, so GGBS, when compared with the other control concrete, it is giving very good results. See, obviously, when structure becomes dense and dense, that means more CSH gels forms, and it gives more durability. Okay, even the initial absorption is improved. That means all the properties regarding durability when compared with the normal concrete is much higher when compared with the GGBS. That's one example I can tell. I have a lot of slides, because this is 1 hour. I cannot put all those slides into it, so I could not able to put that. Yeah, that definitely durability will improve. Can I see the chart? I don't know where to see, because can I have the option to see the chart?
Yeah. In the bottom of your page, participants beside chart is there, sir. Security.
Oh, okay. Participants, okay. Oh, okay. Okay. Bottom, huh? Complete bottom.
Yes. Top.
Oh, okay. There is a 3 lines. Enable waiting room. I'm not getting that.
No, sir.
I have only the option. Yeah. Otherwise, you can read, sir. No problem. Maybe I'm not getting it.
Sir, you have not find it, sir. Share screen is there.
Yeah, share screen.
Besides share screen, there is a chart option is there. Check it once.
There is a your screen, stop share, more, in more, it is, chat is there. Okay. Yeah. Now I got it. Thank you. I'm sorry. Dear Dr. Jagadish sir, this is Neelan Sawant. Neelan sir, how are you? I'm happy to see you. Yeah, thank you for the presentation and good awareness. So thank you, sir. Thank you so much. Why the cubes are immersed in water at above 100 degrees temperature? Somebody was asking, P. Venkat Nagarajan. See, this is an accelerated curing test. Suppose, if you can't wait for the cube strength for 28 days strength, there is a IS 9012 gives you accelerated curing test. So what you can do after cubes are casted, next day to after 24 hours, you can immerse in, that means you are accelerating the hydration process and coming out with some strength and projecting with the actual 28 days strength. So there are two methods. One is accelerated curing, and there is a boiling water method, and there is one more warm water method. So usually boiling water method they use, the formula I have mentioned, IS 9012. That is 8.09 plus 1.6 into RA. So that's why, to accelerate the hydration process, does GGBS in concrete lead to workability issues? Yeah. Somebody was mentioning, does GGBS in concrete lead to workability issues? That is what, when you are selecting the GGBS, I'm very clear about this. So whether is it properly grinded, whether is it processed. So some of the companies, most of the steel plants started selling the GGBS now. Okay. So you have to check, there should not be any irregular shape particles, and you should see that it has got amorphous powder, and also you have to make sure that's why you have to do the initial trials. But most of the processed GGBS, whatever these steel companies are supplying, are tested ones. So you need not worry. Only thing is you have to check the compatibility with the different admixtures and so on. And rate analysis of GGBS in comparison to river sand. GGBS, you cannot compare with the river sand, but processed granulated blast furnace, it is not ground. I mean the sand with the other. I don't know whether they are started supplying, but that time, in the sense in a year back, because the problem is you cannot, when the sand is available nearby, you cannot get through transportation from a faraway place. So right now they are concentrating within 100 kilometers area, and they're supplying. So how heat of hydration is differed between OPC and GGBS? Yeah, it is very well-known fact. OPC heat of hydration, we all studied the heat of hydration because cement, when you add water to the cement, it's an exothermic process, and each time it releases some calories of heat. So GGBS is an inert material, so obviously your heat of hydration is less when you replace the ordinary Portland cement. Dear doctor, please throw some light on flexural strength enhancement with slag-based products. Yeah, flexural strength enhancement, yes, it is there, but it is comparable with the normal concrete, and there is a lot of literature is available. I cannot exactly tell the exact percentages, either equal or little better, I can say. So can I use little amount of sludge in this mixture for replacement of? Definitely for academic purpose, yeah, definitely you can conduct the studies as long as the workability and strength requirements and durability requirements are satisfied. You can definitely use any material, but it should be available in a large quantity, because if it is available nearby and nearby structures, if it is working fine, definitely you can use it. And somebody was saying, if you use GGBS in SCC, what are the things or factors we need to consider while preparing the design? Yeah, very interesting topic, SCC. SCC, you have to make sure that passing ability, self-compactability, segregation resistance are satisfied. Once you look into the new IS code, it is clearly given. So when you look into the slump flow, we don't measure vertical slump flow, we measure horizontal spread. Horizontal spread varies between 500 to 700 or 800 mm. It depends on the type of application. And also GGBS, when you use, you can use, you have seen one of the example in the metro, right? One is this particular paste. So normal concrete, if you take 21 to 23% paste is there. But in case of self-compacting concrete, you have the paste almost like 43% paste, wherein this paste will make the coarse aggregates in suspension while transport also. So homogeneity is maintained. So there are a lot of tests, one L-box test, V-funnel test, slump flow test. So one can measure and design the mix. There are a lot of methods available, Japanese method, Nancy et al. Method, even with my name, there is a mixed design method. And you can refer ICJ journal. You can type mixer proportioning procedures for SEC, you can find out, you can get that paper, not a problem. Is GGBS concrete is used in chemical reaction regions like chimneys and all? Yes, definitely you can use it. Acid and corrosion resistance, it is very good if you replace the GGBS. Can we replace GGBS in plastering mixture? If yes, how much percentage? If no, reason? Yeah, definitely you can use. I have showed it like suppose if you are using a 1:5 cement mortar for plastering, you can replace it to 20, 35, even up to 50% you can replace, and the finishability it increases. What about the flexural strength? Yeah, this is already answered, because either equal or more. I don't have exact data. A lot of literature is there. We have started slag sand in south of India. Oh, great. Neelam Kumar sir from JSW, he mentioned. Oh, very good. So south of India, they started supplying slag sand. Yeah, that is a good thing. Why GGBS is not used that much as compared to river sand? May I know if GGBS is a successful one? GGBS is different. Please, GGBS is a cementitious material replacement. Yeah, his meaning is maybe slag sand replacement to river sand. So as long as government allows you to mine near the river beds, there is no problem. People, river-based cities, they mine the sand and they use it. Once there is a problem, because we have a lot of environmental concerns, people are looking at alternatives. So actually, we have a crushed rock fines. People started, making the sand using the vertical shaft impact crushers, wherein you get a nice sand replacement. That means crushed rock fines you will get. And people also started, using, as I mentioned, near JSW, that Ballari regions, they started using it. So it depends on like whether is it available nearby. So we have like Vijayawada steel plant. So if slag sand is available there, see, one thing is awareness also. A lot of awareness has to be created. Thanks to Chalapathi Institute of Technology for giving me the opportunity to present. So this is the kind of awareness we have to create among the people, and people start inquiring and get the material and started using it. Once you use it, definitely others will also follow. Feedback. I hope. I think almost I have answered questions. If any other questions are there, because this is already 6:18. Okay. Does GGBS hinders alkali aggregate reaction? There are a lot of work is going on. People are, you have to take care. That means you have to check the chemical properties of the what is that? The material before you use it in the mix. How to improve GGBS plus slag-based geopolymer concrete? Yeah, geopolymer concrete setting is one very important thing one has to address. People are producing, particularly for precast applications, geopolymer concrete can be used. But for normal conditions, there are some issues people are sorting out. Can we use GGBS in columns and beams for high rise and small? Definitely you can use. IS also says up to 50% you can use it. Even for HOD towers, they've gone up to almost 50%. I think almost all the questions I have answered. Over to they were saying, sir, GGBS can use in underground water structure. Definitely, particularly marine environment. People are using Portland slag cement. Okay, so in particularly marine conditions, aggressive environments, you have GGBS is a very good material wherein it can resist and it improves the durability of the concretes. Over to the organizers.
Okay.
I think
Thank
I
you, sir.
almost covered.
Yes,
If
sir.
anyone in
Almost-
they can contact me through email or mobile number, whatever. Yes, sir. Over to organizers. Finally, I thank Chalapathi Institute of Technology for inviting me to deliver this talk. Yeah. Yes,
Thank you. Thank you, sir. I express my sincere thanks to our chairman, Sri YV Anjaneyal garu, and Secretary Y Sujit Kumar garu, and our beloved principal K Nagasrinivas garu for encouraging me to conduct these type of webinars for the benefit of students, faculty, and research scholars. I express my sincere thanks to Jagadish garu for accepting the invitation and giving this informative and research-oriented topic chosen for this webinar. Your presentation is versatile and most informative, sir. I extend heartfelt wishes to you on behalf of Chalapathi Institute of Technology, Motadaka, and we always be in touch with you in our future endeavor also, sir. Thank you. I thank Civil Department faculty for the continuous support for conducting this webinar, and I thank all the participants for their patience listening. Thank you, one and all. And feedback form is on. You will get the e-certificate within 4 or 5 days. Thank you, one and all. Thank you, sir.
Yeah, thank you.